we are going to focus on balancing chemical equations. Remember that 4 quantities must be conserved during a chemical reaction. 2 of those quantities are matter and energy. Besides that, the reactants and products of a chemical equation must contain the same types of atoms as well as the same amounts of each type of atom. Coefficients are used in chemical equations to balance the amounts of each type of atom. Let me speak honestly before we get started. Balancing chemical equations can be tough. It can be frustrating. It can make you angry. It can make you want to quit. However, the only way to get better at balancing chemical equations is to practice. So that is exactly what we are going to do. If you come across a chemical equation that stumps you, skip it for now. Maybe after a bit more practice, you'll be able to come back and solve it. I will share with you 3 strategies that I believe can help you balance most chemical equations. But before we get to those, let's try to just balance a few by observation. If you look at this equation, magnesium reacts with oxygen to form magnesium oxide. Let's start by working from left to right, starting with the first reactant. Right now, there is 1 magnesium atom on the reactant side and 1 magnesium atom on the product side. Those are balanced, so we can put a 1 in front of each of those substances. Now let's balance oxygen. There are 2 oxygen atoms on the left side of the equation, but only 1 oxygen atom on the right side. Oh man, now what? First of all, take a breath. You can do this. Let's change the 1 in front of MgO to a 2, so that we have 2 oxygens on the product side. Putting a 1 in front of O2 gives us 2 oxygens on the reactant side. The oxygens are balanced, but since we messed with the coefficient in front of MgO, we have to recheck that magnesium is still balanced. We have 1 magnesium on the reactant side, but 2 magnesiums on the product side. Easy enough. All we have to do is change from 1 Mg to 2 Mgs. Now the equation is balanced. 2 magnesium atoms on the reactant side, 2 magnesium atoms on the product side. 2 oxygen atoms on the reactant side, 2 oxygen atoms on the product side. Go ahead and pause the video right now and try equations 2, 3, and 4 on the balancing equations worksheet. Try to balance these equations by observation. Start with the first element on the left and work your way across the equation. Grab a friend and help each other out. Just make sure that both of you understand what is going on. Pause the video and give them a try. When you are ready, resume the video and I will help you with number 5. In chemical equation number 5, phosphorus reacts with oxygen gas to form tetraphosphorus decoxide. I'm going to give you a strategy to try. If you have trouble balancing an equation or even getting started balancing an equation, this is the first strategy you should try. Put a 1 in for the coefficient of the most complicated thing. I think we could all agree that P4O10 is the most complicated thing in this equation. So let's put a 1 in for that. That means there are 4 phosphorus atoms on the product side. To get 4 phosphorus atoms on the reactant side, we need to use a 4 for the coefficient of phosphorus. Now let's look at oxygen. There are 10 oxygen atoms on the product side. So we need 10 oxygen atoms on the reactant side. That can be accomplished by placing a 5 in this blank. If we take the coefficient 5 times the subscript for oxygen 2, we get 10. This reaction is now balanced with 4 phosphorus atoms and 10 oxygen atoms on both sides of the equation. Strategy 1 cannot always be used, and it may not always work. However, more often than not, it is a lifesaver. Try using strategy 1 on questions 6, 7, 8, and 9. Here's a little secret. It works for all of these equations. Pause the video now and try it out. Resume the video when you're ready to move on. This reaction is not on your worksheet, but similar reactions are. Let's take a look at how to balance it. Aluminum reacts with copper 2 chloride to form aluminum chloride and copper metal. If you start with the first strategy, you might try to put a 1 in front of AlCl3 or CuCl2, but then you would immediately run into issues. Notice that you have an even number of Cl atoms on the reactant side of the equation, but an odd number of Cl atoms on the product side. When this happens, determine the least common multiple. The least common multiple of 2 and 3 is 6. So start by placing coefficients in front of CuCl2 and AlCl3. That will get you 6 chlorine atoms. We will need 3 CuCl2s and 2 AlCl3s. Now balance the rest of the equation. Right now, we have 1 aluminum atom on the reactant side, but 2 aluminum atoms on the product side. We can remedy this by placing a 2 in front of Al on the reactant side. There are 3 copper atoms on the reactant side, but only 1 copper atom on the product side. This issue is resolved by placing a 3 in front of Cu on the product side. Check it out. The equation is now balanced. We have the same types of atoms and the same amount of each type of atom on both the reactant and product side. This reaction is also not on your worksheet, but we will use it to introduce a second strategy for balancing chemical equations. Propane reacts with oxygen gas to form carbon dioxide and water. You should definitely use strategy 1 on this equation, but a second strategy will also be helpful. Wait to balance hydrogen and oxygen until last. And in addition to that, save any element that appears in more than one product or reactant until last. Do you see how oxygen can be found in both products? CO2 and H2O both contain oxygen atoms. Oxygen atoms will definitely be the last thing I balance. I'm going to start by applying strategy 1 to this reaction. C3H8 looks like the most complicated, so I am placing a 1 in this blank. Now apply strategy 2. I'm going to balance carbon first, then hydrogen, and then oxygen. Hopefully by doing this, the oxygen atoms end up balancing themselves out. There are 3 carbon atoms on the reactant side, so I need 3 carbon atoms on the product side. This can be accomplished by placing a 3 in front of carbon dioxide. Now, I have 8 hydrogen atoms on the reactant side. To get 8 hydrogen atoms on the product side, I should use a 4 for the coefficient of water. 4 times 2 is 8. On to the oxygen atoms. On the reactant side, I presently have 2 oxygen atoms. On the product side, there are 10. 3 times 2 here in carbon dioxide gives me 6. 4 times 1 in water gives me 4. That gives me a total of 10 oxygen atoms on the product side. Well, to get 10 oxygen atoms on the reactant side, I will need a 5 as the coefficient for O2. There you have it, a balanced reaction. Let's have a look at number 10 on the balancing equations worksheet because it is very similar to the last reaction. Once again, I will start by applying strategy 1 to this reaction. C2H6 looks the most complicated, so I'm placing a 1 here. Now apply strategy 2. I will balance carbon first, then hydrogen, and then oxygen. The oxygen atoms should be easier to balance by following this strategy. There are 2 carbon atoms on the reactant side, so I need 2 carbon dioxide molecules on the product side. Now I have 6 hydrogen atoms on the reactant side. To get 6 hydrogens on the product side, I should use a 3 for the coefficient of water. 3 times 2 equals 6. Let's attack these oxygen atoms. On the reactant side, I presently have 2 oxygen atoms. On the product side, there are 7. 2 times 2 equals 4 here in CO2. 3 times 1 equals 3 here in water. That gives me a total of 7. Well, to get 7 oxygen atoms on the reactant side, I will need to use a fraction, which is okay. What times 2 gives me 7? That's right, 3.5. I can place a 3.5 here for the coefficient of O2, and the reaction is balanced. Now, if you are like me, you hate fractions. So we can simply multiply all the coefficients by 2 to get rid of the fraction. This would give us coefficients of 2, 7, 4, and 6. It is not necessary to have a whole number of coefficients. However, just an FYI, I will always multiply to get rid of fractional coefficients. Okay, time to pause the video and try a few of these. Utilize strategy 2, and maybe even strategy 1 on numbers 11, 12, and 13 on the balancing equations worksheet. When you have those reactions completed, press play to resume the video and learn about the third and final strategy. Oh my goodness, look at this nasty reaction. How are we even supposed to balance this beast? You can do this by applying strategy 1 and strategy 3. There might be some debate, and you may have to do some trial and error, but CO3 PO42 looks like the most complicated thing. Let's put a 1 in front of that. Now apply strategy 3, which is balance groups of atoms instead of individual atoms when possible. Many times, groups of atoms are easy to identify because of the parentheses. Notice that 2 groups of atoms appear on both the reactant and product side of this equation. NO3 and PO4 appear on both sides of the equation. Instead of balancing the nitrogen atoms and the oxygen atoms in NO3 separately, simply balance the entire group of atoms. Same with PO4. This makes balancing this equation much, much easier. So since we put a 1 in front of CO3 PO42, we have 3 cobalt atoms on the product side. To get 3 cobalt atoms on the reactant side, we will need a 3 right here. Now balance the PO4 group. We have 2 PO4 groups on the product side. 1 times 2 equals 2. So we need 2 PO4 groups on the reactant side. Right now there's only 1. Let's put a 2 right here for the coefficient of Na3PO4. Now, let's hit the final blank for NaNO3. NO3 can be balanced as a group of atoms. Since we put a 3 in front of CONO3-2, that means we have 6 NO3 groups on the reactant side. 3 times 2 equals 6. Therefore, we need 6 NO3 groups on the product side. This is accomplished by placing a 6 in this blank. We better check to see that sodium atoms are balanced as well. On the reactant side, we have 6 sodium atoms. 2 times 3 equals 6. And on the product side, we have 6 Na atoms. 6 times 1 equals 6. This nasty reaction is balanced. Using strategy 3 took a complicated reaction and made it easy. Try implementing strategy 3 as well as strategy 1 on problems 14 through 19 on the balancing equations worksheet. Balancing chemical equations can be tough and frustrating and hard and infuriating, but it is not impossible. You have to practice to get better. Practice by completing the rest of the equations on the balancing reactions worksheet. Implement the strategies. They don't always work, but many, many, many times they will make your life easier. Time to practice balancing. So until next time.